Okay, so let me go through more. In particular, I want to talk about this. How do we arrive at this? Why is tangent x approximately x? Let's work through with this problem, but you note the powers in the question. So for such questions, they will mention sufficiently small. But this phrase, I should emphasize, when you see this phrase, this is completely useless to you. It's not important. What is important is what comes next. You want to know what terms to neglect. I am saying it is small, or they are saying it's small for x power 4 and above to be neglected. So you note the power given. They may change the power anytime. It may not be true that it's always cube and above. It could be power 4. So can we get the Maclaurin's expansion for tangent x? When they say Maclaurin's expansion or they say binomial expansion, they are referring to the same thing. These are equal to each other. Binomial expansion is just one type of Maclaurin's expansion. So don't bother too much with the phrase. Basically, you want to expand. Okay, so let's start with tangent x first. I want to go up to degree 3 because degree 4 onwards is neglected. To use the formula list formula, I will have to go for sine over cosine. But it's degree 4 onwards neglected. So for sine x, you cannot stop at x. I must go to x cubed over 3 factorial because they say degree 4, then you neglect. Okay, so there will be a change here. Instead of the usual x, you must continue with the next term. X cubed over 3 factorial is 6. Cosine x will just be the same two terms, degree 4 and above neglected. So you have this. Anything from the denominator, we now move it up as power minus 1. Let's expand it further. The front part, let me just close up. For your second term, to expand a power minus 1, let's use the binomial expansion formula. So 1 plus nx n times x. I don't need the next term because the degree will exceed 4. It will be degree 4 on the next term, so we don't want that anymore. Okay, let me further simplify it out first. You would like to expand, but only keep up to the cubic term. Let me expand slowly. I want to expand these green terms first. And then I expand for this red color term. The rest don't need because the power will be too large.